Hello, my name is Maria Burns, and I will be presenting on understanding different forms of color blindness. Protanopia is a form of red-green color blindness characterized by a lack of sensitivity to red light. This spectrum illustrates the difference in color perception between a person with normal color vision and a person with protanopia. Protanopia is caused by a lack of functioning red cones in the eye, while the blue and green cones still work. Cones are responsible for color vision in humans, so a lack of functionality in one type can affect its ability to interact with the other types and create the color spectrum seen by those with normal color vision. It is an X-linked recessive disorder, meaning that the genes responsible for the defect are located on the X chromosome, and that an X chromosome containing the normal gene is dominant to the malfunctioning gene. Protanopia affects 1.01% of males, while it only affects 0.02% of females. This is due to the fact that males only have one X chromosome, so if they receive a damaged gene from their mother, they will have the defect, while a female would need a damaged gene from both her mother and her father, which is far less likely. Deuteranomaly is a form of red-green color blindness characterized by a lack of sensitivity to green light. This spectrum illustrates the difference in color perception between a person with normal color vision and a person with deuteranomaly. Deuteranomaly is caused by a malfunction of the cones of the eyes, in which the blue and some red cones are functional, while some anomalous red cones are also present. The severity of the color deficiency experienced can vastly differ from person to person. Deuteranomaly is a relatively mild form of color blindness and can exist without detection for many years until the subject is tested. Deuteranomaly is also inherited in an X-linked recessive fashion, but it is a much more common color deficiency than protanopia. Approximately 5% of males have deuteranomaly, while only 0.1% of females do, owing once again to the X-linked recessive nature of deuteranomaly. Tritonomaly is a form of blue-yellow color blindness characterized by a lack of sensitivity to blue and yellow light. This spectrum once again illustrates the difference in color perception between a person with normal color vision and a person with tritonomaly. Tritonomaly is caused by a malfunction of blue cones, which are also referred to as the S cones of the eyes. This stands for short wavelength cones. In tritonomaly, the S cones are mutated. Therefore, the partial lack of functional S cones causes not only blue, but also yellow and violet shades to become abnormal. Tritonomaly is inherited in an autosomal dominant fashion. This means that triton defects, unlike those for red-green color blindness, are not located on a sex chromosome and are in fact located on chromosome number 7, which every person has 2 copies of. Because it is dominant, if one case of the mutated gene is found in a subject, the mutated gene will overpower the normal gene and cause the person to have the disorder. Tritonomaly affects 0.0001% of all individuals, which is about 1 in 10,000 people. There is no difference between the probability of a boy or girl obtaining the mutation because of the autosomal nature of the disorder. Rod monochromacy is a form of complete color blindness in which the afflicted person does not have the ability to see any color and instead sees various shades of gray. This graphic displays the grayscale vision of a person with rod monochromacy when viewing a colorful bouquet of flowers compared to a person with normal colored vision. In this form of color blindness, the cones of the eye are usually not working at all. It is possible that the cones are absent, have an irregular distribution, or that they show abnormal shapes as well. Rod monochromacy is inherited in an autosomal recessive manner, referring to the fact that the gene responsible for the defect is located on chromosome 2, which is not a sex chromosome, and that 2 copies of the defective gene are needed in order to have this color deficiency. Rod monochromacy is very rare, as only 0.000025% of people have it, or about 1 in 40,000 people. Once again, this disorder affects men and women the same, as it is not sex-linked. This concludes my presentation about various types of color blindness. Thank you for taking the time to listen to it, and I hope you have learned some valuable information.